I'll see if I can record the lectures on here and put them on the YouTube for you. Yeah, here we go. I haven't finished this setup yet. Hopefully the PDF files of the lectures I can somehow get to you. I'm going to try to share my OneDrive folder so you can access it. I'm not ever sure if that's going to work or not. I'll figure out how to get them to you one way or another. But for the book, right here under Files, boop. I'll just download it. Download. It's a PDF. It's free. And hopefully y'all can download. Have y'all all downloaded it? I think you can get a physical paper copy for free at the bookstore if you want, right? Okay, cool. I can save the files. I'm gonna put this on my desktop. Where's it saving it to? I don't know. Wherever that is, okay. I've watched the interfaces for computers evolve over time to get worse and worse. It used to give you like, here's your hard drive, make a folder. You have folders inside of folders. Here's the hierarchy, put it wherever you like. But so many people just randomly just clicked save without thinking that over the last 20 years, the whole interface is geared towards the average person who is a person that just clicks save and have no idea where it went. So now all you have is like 3 different versions of shortcuts. If you actually want to navigate your folder system, that's hard to find, which is very strange. That's math, organization, keeping things organized. Why? Well, what do you think thinking is? How do you think? You have a brain, right? And you have a neural network, and it produces what you call your thoughts. And that's who you are, the sum total of the thoughts you have from the moment you're born to the moment you die, right? How many of y'all think about the difference between the words what I think, what I know, what I feel, what I believe, what I'm aware of? Those are all different things, aren't they? Most people will use them interchangeably. I know, or I think, or I believe. They just say that like it's the same thing, but they're not at all the same thing. It's very important to start distinguishing those. Now, don't look to a dictionary to know the definition of these things. Think about them for your own self and define them for your own self. So as you grow and age and become more wise, the definitions of all the words that you know and will eventually know should evolve along with you, because it always depends on context, right? What is true? Just truth. You might think you know the difference between something that's true and not true, but it always depends on the context, really, right? I'm sure you've had arguments with people before where it's like, it's obviously what you're saying is obviously true, right? But if you make your context big enough, you can find a reality large enough where it's no longer always true, right? Or you get in an argument with somebody and it's like, clearly they're nuts, they're definitely wrong. But then you figure out that what they're doing is they're shrinking their reality so that their whole worldview is so small that in that worldview, sure, by the same logic you use, they are right, but only right in that tiny little context. It's really aggravating when you argue with people, and in one argument, they shrink their reality tiny over here, and then the next day it's a different argument, and they shrink the reality tiny over here. 2 different tiny realities that might have a little bit of overlap, right? Or not. And they don't see the inconsistency between their reality from one day to the next day. You can never win arguments with those people, right? So the scientific method, like you come up with an idea. Is it right or is it wrong? I don't know. And then you look for evidence to figure stuff out, right? The most important difference that most people, the vast majority of people, don't realize is scientists don't come up with facts. Scientists are always wrong. What we do is we develop a model. And a model doesn't have to be perfect. It just has to be useful. In fact, it can never be perfect because everything really has an infinite number of variables to consider, and we can't do that as humans. So some people come up with a belief, and then they look for evidence to support that belief, right? Well, that just leads to mass insanity. It really does. So here's a trick that you can play. Come up with an idea that's obviously just ridiculously just not true, okay? And throughout your day, look for evidence to support it. You'll find an infinite amount. And this is why most people in our society are just totally insane. Okay? Because that's how they operate. The scientific method, you come up with a hypothesis, and then you look for evidence to refute it. You assume you're wrong, and you look for evidence to see how you are wrong. And then once you get the evidence and you see how you're wrong, then you change your hypothesis to fit the evidence. And when you do that, you're okay with being wrong. That's how you learn and grow as a person. You will always be wrong, but you will become righter and righter and righter and righter as you grow and become wiser. Your reality will get larger, not smaller, okay? And you'll be comfortable with being wrong. Being wrong is great, okay? If you're right, there's no room for growth, okay? That's why the vast majority of adults are really just old babies. Pretty sure most people after the age of like 12 get dumber. I mean, really all they have to do is just succeed in our society is get a job. They don't even have to be good at it. They just have to not get fired. And if they get enough money to pay their bills, other than that, they could just be wrong about pretty much everything in their entire life, and it doesn't matter. No repercussions. They get to grow old and judge other people and vote and control everything around you. It's really a horrible, horrible situation. This is why, like, the whole planet, we are like collectively 7 billion of us just doing everything we can to destroy the earth as fast as we can, even though we depend upon it to live, right? And we're like, well, I don't know. There's nothing we can do about it. Yeah, there's a lot we can do about it. Just stop doing that, right? But you can't convince 7 billion people of anything, right? Actually, it's easier to convince everybody of pretty much anything you want than it is to convince one person of something, right? Consider your parents, right? Trying to point out the obvious. They'll never believe you. It'd be easier to get the whole world to believe something rather than get that one person to like believe that one thing, right? It's crazy how that works, right? So one thing you need to understand is everybody, in quotes, is wrong about almost everything, almost all the time. They have been always forever. And no matter how smart or dumb or slow or fast or whatever, however you judge yourself, which by the way is a waste of like cognitive time and energy, right? You have the ability to instill positive, lasting impact on humanity that can affect everybody on this planet now and forever. It doesn't take much. You are a living human being and you have a brain, and it's one of the most powerful things we know of in the entire universe. The complexity of it is the most complicated, complex structure we know of in this universe at that scale. Most people know stuff. I have a 5-year-old daughter. Her classmates in pre-K are geniuses, every one of them. I can ask them a simple question that requires thinking, and they will think about it, and they will answer the question correctly. Then I'll come to the university, ask my grown adult students the exact same question, and the look on their face is like I just turned their brain to mush. They're like, oh, I don't know. Because they're trying to know. They've gotten brain damage from math class. Like they literally cannot think anymore. They don't know what thinking even is. You can see their brain is spinning. They're going through their database. Do I know this? Do I know this? Do I know this? They don't even bother to see if they understand the question. They're just trying to associate the right answer to the right question so they can get the grade without understanding anything. It's just a massive charade. And unfortunately, this is what math classes have become. That's why everybody hates math. They don't hate math. They don't know what it is. The math teachers don't know what it is. What they hate is math class, which they should. If you knew what I knew about it, you would hate it even more. As a living, breathing, biological entity, the one thing you get to do that non-living things don't is think. A piece of paper knows whatever you write on it forever without effort, doesn't it? That's why we invented writing. To me, the invention of writing is math. We are lazy. Everything in the universe is lazy. All physical systems try to find a minimal energy state to exist in. We don't like doing mundane tasks, especially repetitive ones. That's why we always invent tools to do that for us, right? Mathematics is what living things do to become more alive. Thinking. I think, therefore I am, right? So inventing writing allows us to take these cognitive tasks and offload them to non-biological matter. So by writing the stuff down on paper or papyrus or clay tablets, that frees up neurons that you can now use for thinking instead of just boring old storage that dead things could do for us, right? Adding, multiplication is just repetitive adding. Nobody wants to go 2 plus 2 plus 2 plus 2 2,000 times. That would take all day, right? And we're lazy. So we came up with this idea called multiplication. And now you can do it instantly. Now that operation happens actually in your neurons, not on paper, but hey. Then we invented calculators. That used to be a job by a human, right? The job title was calculator. Because a lot of math had to be done, like during wartime and stuff, was really important. And the jobs were almost always held by women because at that time it was assumed women couldn't think. You know, it's just the way it was. The scientists were the men, the calculators were the women. Super sexist, right? That was the era when math education as a subject, a degree plan, was invented because it was really important that we get a lot of people that were good at being calculators. And then we invented calculators and they never got the memo, right? So math classes for the last few decades have all been about making you compete with dead objects. Mathematicians invented calculators to free up our minds, our brains, to do cooler stuff like thinking. So the boring stuff that is just calculating, which doesn't require thought at all, can be done by a dead object, right? So to have you spend your first 12 years of life coming forced by law to go to school and sit through the one class that's supposed to teach you how to think, but instead is forcing you to compete with a dead object, memorization, piece of paper does that. Calculation, calculators do that. Instead of creative, critical thinking. And then punishing you if you actually do that. You didn't do the problem the same way I told you to do it, so therefore it's wrong. That's torture. That's quite literally sucking the life right out of you because thinking is the one thing you get to do while being alive, right? And they told you, don't do that, and they occupied all of your youth with doing not that and punished you if you did that. It's basically killing you every which way they possibly could except biologically, turning our entire society into the walking dead. Most people cannot think. They will not. If you pose a question to them that's a thinking question as opposed to a knowing question, you will see their face emit physical pain. We don't like thinking for the same reason we don't like going to the gym. We evolved this way. For millions of years, food was hard to get, right? You never knew when your next meal was, okay? So you didn't waste calories because your brain uses 20% of your calories even when you're sleeping. You're not even doing anything. It's very energy intensive. It takes a lot of energy to process that information flowing in through your sensory inputs, okay? That's why your filters of perception filter out most of that information, right? Okay? So thinking takes more energy as far as processing with your brain than just knowing. Because knowing, you're just consulting your database. Here's some neurons, they store some data. Is it there, is it not, right? Versus trying to figure out something that requires unique creativity. Every time you think, your little neurons have to do stuff. Like your thoughts, they exist in this universe. You observe them, right? Yeah, I assume that you'll have thoughts like me, right? I studied cosmology, which is like the physics of everything in the whole universe. I dropped out because like the equation for everything ignores the fact that thoughts exist. Now, we know the universe is this big and this old and all this stuff, yet 96% of the known universe that we know is there, 96% of it we don't know what it is. We call it dark energy and dark matter. Well, what is it that we do know exists? Our thoughts. They just ignore that. They ignore the fact that thoughts exist. They're missing 96% of the universe, right? And the simple fact of it is we've never observed anything other than thoughts. Science is an observational thing. You have to observe stuff, right, to confirm it. You don't see anything. You think you saw. When the photons of light hit your eyes, it takes a tiny fraction of a second before your brain recognizes that you saw something. And what you think of as this fluid video that you see as you look around, that's not real at all. What your brain is actually receiving is flashes, a picture, a picture, a picture, a picture. That's what's actually going to your brain. All the rest of the stuff that you're seeing, your brain just made it up. It just assumed that based upon past experience and millions of years of programming, as you evolve, become what you are. So you don't see anything. You think you saw. You think you hear. The only thing any human being has ever observed is thoughts. Yet our physicists doing the equations for everything totally ignore the fact that they exist. And then they wonder where the 96% of the universe is. Duh. Well, the universe is getting bigger, and it's getting bigger at an accelerated rate. Well, yeah, it's making room for thought, right? So I'm going to teach y'all how to engineer your brain. Every time you think, that thought exists because there's a physical neural network that is now present. If there's an idea and you don't get it, it's because you do not have the physical neural network in your brain that's logically equivalent to that idea. Now, when you learn math, you might not ever apply the math ever directly, right? You're like, I hope not, right? Well, every time you learn something new in math and you have that aha moment, you're like, it's because you've been thinking about it, and your little neural network, every time you thought about it, even if you got the right or wrong answers, not relevant, your little brain cells are all like moving around and twisting around. So just like you build muscles in the gym, same thing with your brain. You can't go to the gym for 40 hours straight and come out buff. Go a little bit every day, right? It's a physical, slow process. Same thing with your brain. You'll sculpt this neural network, and every time you have this new aha moment, and now you understand this new idea, well, guess what? Now you can understand and perceive any idea that's logically equivalent to that physical structure. So that information flowing in through your eyes and ears and stuff, that sensory input info, instead of the brain just filtering out everything as you learn new stuff, now it won't filter that out. So think of your brain like as an antenna, okay? Catching different frequencies, if you will. It will now take in that frequency instead of ignoring it. And then it'll look at it and compare it with the rest of the data and go, is this important? Is this consistent with everything else I'm experiencing? Should I process it a little more or not? It's gonna add to the water that is your unconscious mind, that ocean of unconsciousness. And the waves pop up here and there, and that's what produces your conscious thoughts, the thoughts that are in your head that you perceive. Y'all have words go through your head, right? Pictures, sounds, such, right? Notice the thoughts that you can observe are only the ones that will fit through somebody else's physical sensory inputs. You observe pictures. because you can share a picture with someone else. You can shove it through their eyes, right? You can imagine sounds in your head. Well, that's because the person next to you, you could shove the sounds through their ears, right? So it's like our brain evolved for you to only be able to perceive the thoughts that fit through somebody else's physical orifices. Well, I don't have to share my thoughts with anyone, do I? But unfortunately, there's already this restriction for myself that I can't perceive the other thoughts that aren't pictures, that aren't sounds. There's an infinite amount of types of thoughts you could have, right? But the only ones that I can see directly are the ones that I could share with somebody else. That's weird, isn't it? Well, consider this. What if you'd had never ever met another human being? Would you even have a concept of an I or me or mine? Would you have this ridiculous idea that you actually end? If you don't have an idea of a you, because there's never been anyone else, you wouldn't even have this thought that you end at your skin, would you? Maybe that's just an optical illusion and nothing more. Because everything's made out of protons and electrons, just like your brain. Turns out all matter is brain matter if you make it behave as such. All right? You got neurons that make your heart beat, and you don't have to think about it. When you go home, if you have a hook that you put on the wall where you put your keys every time you walk in the door, then every time you leave, they're right there and you grab them. And you don't even have to think about it, do you? It's just done. You're just all of a sudden in your car is started, you're on your way. Some people go home and every day they put their keys in a random spot, and then every time they leave, it's like this battle, right? So that hook is doing the same thing the neurons do that make your heart beat, but they're doing it for your keys, making this happen for you without you having to even think about it. You are the entire universe. This illusion that you end at your skin is just a consequence of other people being present. And what are other people? Just piles of protons and electrons that are similar in structure to the pile of protons and electrons that you call yourself. It's really hard to see what's really going on around you because of words. They evolved from pointing and grunting. Like literally pointing and grunting, right? Lion, food, whatever. So it's an inside to outside point of view, and words slowly got more and more complicated so that we could share information from one person to the next. Basically 2 points in the universe having information flowing between those 2 points in the universe, because you really are just a moving volume of space and time, right? That the universe decided to label itself. Okay? Now, when I was your age, well, my first 6 years of college, I was an idiot. I was one of the least interesting, uninspired, boring people you could ever meet. And then I realized what science was, and math finally clicked. I was like, this stuff actually says stuff, you know? It's not just memorizing boring garbage, you know? And that's when my life changed. And from there, it's amazing how aware you can become and how quickly you can become. It comes down to compassion. Scientists, what we do is we try to instill positive, lasting impact on humanity. I was just a moron from the hills, but that was my job. Even if I could contribute the tiniest little thing or maybe even nothing, my job was to at least try. And that's where it all started. When you start considering other people, well, because if you're compassionate, you consider other people. If you want to help people, you don't just press your help button. No, you have to actually look at their situation and the uniqueness of that situation and make sure that what you're doing actually helps them in their situation, right? You don't just look at their situation, see something you recognize, and then just judge it, single variable judgment, boom, and then do something. That would probably make things worse, right? Considering people like that requires actual thinking, and actual thinking is what makes your brain actually grow. And when you get more and more and more of these neural networks, you're now perceiving more and more and more, which means what you are as a sentient being is becoming more. There is now more of you. You're more alive. Okay? And this is what I like to do. I like to create life in this universe by engineering your brains. And you can't talk to people directly most of the time because we're restricted to these words. And all the words we have inherent judgments built into them. There's connotations built into the words. And most of the time you might not even mean those judgments or connotations, but that's all we got is words. Words were made by people to talk to people about people stuff. Like, I like blue. And, we are 0% of the universe. And your mind is not limited to the language of your mouth. You need the mathematics. There's one thing to write math. There's another thing to think mathematically. Every single thought you have is a mathematical construct. You are all excellent mathematicians, no matter what any math teacher ever told you. They don't know what math is, okay? You are geniuses, every one of you. And if you want to change the world for the better and leave an imprint of you on this planet for eternity, all you have to do is learn how to feel free to be. Just feel free to be you. The first step to success is feeling free to fail, right? There's lots of buzzwords, right? I mean, think about it. If you ran a race, every single step you take, well, you're a loser because you didn't pass the finish line with that step, right? That's kind of how most people perceive people around them. It's just constant judgment. It's built into the words that we use to try to think with, right? So anybody running a race, every time they take a step, well, you didn't pass the finish line. Loser. So it's like loser, 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 every single step of the way until you win. Well, that's not a very good outlook. That's going to really repress you, right? So anytime you're doing something great and amazing and original and unique, expect the entire society around you to beat you down. Passive aggressively for sure, okay? If not aggressively, okay? That's just the way it is. That's why a small handful of people in this world, all they did was feel free to be and follow their curiosity. They're the reason why we have electricity and walls and bottled water. Every single comfort that you have in your entire life came from just a handful of normal people, and all they did was simply feel free to be. And they came across these discoveries, and they were credited with these amazing things, right? They weren't the first person to discover that. They were the last. See, these ideas, the next idea is going to be the tiniest mutation from the last idea. If it's too much more of a mutation, it's not going to survive, just like an animal species evolving. If it's too much of a leap, it won't be able to breed successfully with another animal to have offspring. It'll die out. If you have a cool idea that's super useful and awesome, but it's too far ahead of what the collective is aware of, they either won't be able to understand it or appreciate it, and that idea will die out. So any idea that's become part of our collective reality has emerged in this universe many, many times and died out with the host until finally the universe put it in the right spot. And then the environment was fertile, and that idea popped out of that one person and spread amongst all the other people like a virus and became part of our reality, okay? It's exactly the same math and physics. It's fun to look at us from the outside in and treat us as physics because we are part of the physical universe, right? It's really the only way to see what's actually happening, because then you can describe things without words. You don't even have to write it down. Y'all think all the time, but you don't have to write stuff, right? Everything we learned about math is so weird to me. Are you doing math? Are you doing English? That doesn't make any sense, right? What do you mean doing math? You mean writing symbols down? Is that what is doing math? I want y'all to think, what the hell is math to you? And forget about everything you know. The hardest part of my job is deprogramming the brainwashing, trying to get y'all to simply think instead of, do I know it? Do I know it? Do I know it? I do it constantly. I'm still trying to deprogram myself. It took me 25 years, and I just recently learned what arithmetic was. Just a few weeks ago, I finally thought about what adding is. I was inspired by my 5-year-old, trying to teach her, blew my mind. Like, my brain opened up so much, because I always just ignored arithmetic. I was taught by math ed people, and I just memorized it, did the little routine, and ignored it, To me, that's it. I don't know, as a mathematician, once you get to actual number symbols, you box it. I don't simplify it. That's a calculator's job, right? But then I had to think about it. It's like, what is addition? That's, y'all probably spent 12 years in math classes and you learned nothing. Absolutely nothing. You might know some stuff, understand absolutely nothing about it, right? What a complete and utter waste of time. Most of my science algebra students still can't add fractions. They end up in calculus 2 and they can't add fractions. We're doing something terribly wrong in math class, aren't we? The vast majority of people hate math and they suck at it, right? Well, I think that's the teachers. But these math ed people who have politically maneuvered to take over, and they shun mathematicians and scientists straight out of the profession. They will not allow us in here. I don't know how they let me here still, but it's a problem. I intend to remedy that. So these symbols, like, y'all know, come here, buddy, pen, there. Y'all know these. I'm gonna teach you all of math that you missed in like a week, and you were gonna understand it and be like, this is so cool, why didn't they do this? What are these? These are just symbols. These are shortcuts. Remember, everything we do is out of laziness, because all physical systems want to go to a minimal energy state. We started off without numbers. That sucks, okay? How could you exist without numbers? There are still cultures out there, and their only numbers are 1, 2, and many. All right? So let's say you're like a shepherd or something, and you're, I don't know any of this terminology. You're female sheep, they don't have babies for a long time. You're like, man, I'm hungry. And then one year, suddenly all the women, they all have babies in the same year, and now you're overrun with food. And you're like, oh, okay, well, you need to be able to barter and trade, right? You need to go to town, and you're going to trade some of these baby sheep to get some other stuff that you need, right? But you can't haul all these sheep to town, but you want to get there and tell people how many you got for trade, right? How would you do that if numbers don't exist, which they just recently were invented? So for millions of years, people dealt with things without numbers. How would you do it? This is how I finally learned what math really was. This is how I learned a lot of things. It's a trick. I started learning hand tools. Doing home maintenance because I couldn't afford to do myself. Go to Home Depot. There's so many tools and adapters. And I'm like, oh God, hours. I figured out how to figure it out, right? That's what I'm going to teach you. Not problem knowing, problem solving. What you do when you don't know what to do. There's tricks, okay? So imagine a situation where you would normally use that tool, whether it's a mathematical idea or whatever, and then pretend it doesn't exist. How would you do it without that tool? Then you go, oh, that's how you appreciate the tool and understand what it really is, right? So that's what we're going to do with the math here. So how would you go to town and tell the people there, I have this many sheep? What do little kids do before they know numbers and you ask them how old they are? That's right. They hold up their fingers. They go, I'm this many old, right? That's why we use a base 10 number system, is because for millions of years, if I needed to represent a quantity, if it's less than 10, you use your fingers every time. It's ergonomic, right? That's why. Ergonomics, our fingers, they're right there. If there's more than 10, you might use pebbles, and that's what they did. So the farmer looks at the shepherd looks at the sheep. He looks at one sheep, picks up a pebble, looks at the next sheep, picks up a pebble, and he just has a handful of pebbles, one pebble for each sheep, goes to town, and boom, shows them the pebbles. This is how many I have, right? That's how they did it for millions of years. This is probably the reason we trust money. Otherwise, can you Look how ridiculous it is. Here's a piece of paper. We don't trust one another at all, do we? At all. But for some reason, this piece of paper, we trust that it represents something, right? I think it's hardwired into us for these millions of years that we used pebbles or seashells or whatever to represent actual value. Otherwise, we wouldn't be doing that, okay? So we did that. But eventually, that sucks. What if there's a whole lot? Once things scale up and you're running like taxes for the Roman Empire or whatever, that's just a lot of pebbles, yeah? What if there's no pebbles and it's just all like clay, dirt? You can't find any pebbles, it's clay. Maybe that's when they invented clay tablets. They picked up some clay and they're like, well, instead of making clay balls, I'm going to smash it flat and put a little tally mark in it, and that's going to be a count, right? So, tally marks. 1. I have this. Come here, pen. I have this many. I have this many. I have this many. I have this many, and I have this many. Right about here is where it's a problem, and it's a limit of our biology. I can tell these apart really easily. Once you get to 4 and 5, a quick glance, it's hard to tell the difference. You see that? And we're lazy. We want to be lazy, but we want to get the job done with minimal work, and that's a problem. So once you have a job and you're doing something basic, like there's 4 of something versus 5 of something, and you have this problem where something gets screwed up because you thought a 4 was a 5 or a 5, and it's wasting your time. You're like, I'm lazy. How can I be lazy? Because this problem is causing me, like, I'm not getting to be lazy. This sucks. How would you fix it? You look at your hand and you borrow a visual cue from your hand. Your thumb folds over, doesn't it? And so you're like, oh, well, this will also save some space, right? Because also you're putting these tally marks. Why do we do it like that? Why don't we do them like this? Why wouldn't we do them sideways like that?
Takes up a lot of space.
Yeah, end to end, it would take up more space. And I can only reach this wide with my arms, right? So you would run out of space faster, yeah. Okay, well, that's good. Now, why don't we do it like this? Top to bottom instead of left to right. Some languages, they write top to bottom instead of left to right, don't they? But why is the predominant way left to right in a horizontal fashion? Why would you think? The things I'm sharing with y'all are hunches. They are thoughts. It's not anything I know that can be verified. Most of these things happened eons ago. It's impossible to know. We don't care about knowing. I don't care about what anybody knows. Nobody knows anything, okay? So, what's your hypothesis?
I don't know. That's how I read left to right. I mean,
Yeah, but why do we read left to right? It's the same thing. We are writing, aren't we?
Yeah.
We are writing, huh?
In Latin, weren't they the ones who invented the left to right? Or I don't remember. I know there was,
I don't know either.
people.
But I do know most of the writing is left to right. Some are up to down, but the prevalent way to display symbols on a flat surface for recovering that information later is left to right. Why are your eyes like this? Why aren't they like this? Now we need 2 of them so we can get 3D. Without 2 eyes, you don't get to see depth, right? That's why we have 2 eyes. But why aren't they on top of one another? Why are they side by side? Millions of years, they slowly got that way. It's almost true of almost all animals. I don't know of any animals where the 2 eyes are on top of one another. I mean, some animals like spiders have 8 eyes and stuff, right? All right, so imagine you're hungry. For millions of years, you need to eat, sleep, and poop, right? So eating. Where do you get your food? Well, there's animals and plants, right? So if you're looking for animals and plants, and you need to find it, whoever finds it easiest survives with spending the least amount of energy, right? Whoever gets to survive the most lazily is the most successful. So where do you find food? You look around for it, right? That's why we have the eyes, to see the food, to catch the food, to eat the food, right? Well, where is food most likely going to be? Below you? Straight up? Well, let's see. We live on a planet that's round, right? But it's so big that if you're standing here, it looks like that, right? Yeah? Is the food going to be up here or down here? It's most likely going to be on the surface of the earth, right? It's mostly going to be here or there, from left to right. That's why our eyes are on left side and right side, yeah? That's why your peripheral vision is more wide than it is tall, because that's where the food's going to be, or the thing that's going to eat you. Make sense? Hence left to right. Do I know this? I don't need to know it. I am confident in my mind. Most people can't judge their own judgment. That's why they don't like thinking. What do they call knowing? They know something because somebody else told them. Ultimately, that's what it comes down to. You ask people how they know. Oh, well, somebody said it. Well, how do you know they're right? Oh, well, they're smart, or they have fake credentials, like they own money, or they have a diploma, or whatever. It's like, well, there's just people like you, right? And it all comes, their circular reasoning will all come down finally to, well, somebody else told me. Well, aren't you comfortable in like thinking for yourself and validating your own thoughts, right? That's what I want all of y'all to have. I want y'all to reclaim that self-confidence that math ed stole from you in the math classes, so that every day you can become more alive and more you, that bandwidth that is you in this universe. The quality and the amount of thoughts that you create in this physical universe, I want them to be more, not less. Be careful though, it can be scary. It's weird to be a sphere in the land of circles. Okay? They will gang up on you. All right? I want y'all to be the higher dimensional beings, not the lower dimensional beings, okay? So, tally marks. That's what happened. We did this. But hey, if I'm doing tallies all day long, tally, like it's my job, you know, I realize when I do this one, I only do that after I do the first 4. And I'm lazy. If you actually did these things, you would very quickly, if your job was like, 1, 2, 3, in about 30 seconds, you would quickly go, I'm just going to do this because I only put that after I put the first 4, wouldn't I? Save myself time, yeah? You do it all the time when you're texting. You could leave out a bunch of crap, right? Yeah, it's because you're excellent genius mathematicians. Okay, so you're like 5, right? 5, you're all super fast, and 5, and you're like, wait, crap, is this a 5 or a 1? That was sloppy. Now you have this new conundrum, the same kind of conundrum between the 4s and the 5s, right? You needed to disambiguate them. Now you have the same kind of problem. Is it a 1 or a 5? I was doing it real fast. It's kind of slanted, but is it slanted enough? And I don't want to have to be all like super like every time I do a 5, making sure it's at a perfect 45-degree angle. That would suck, right? Is there a faster, easier way to do this? Now you have to be a mathematician again and create. Every one of these little things took thousands of years, right? Many human beings, billions of hours of like labor, people going, this sucks. And finally somebody fixes it. Dude, I looked at a sewing machine the other day. Like, how did they invent that? If you think about the many, many people and the many, many hours of people doing stuff that sucked for so long, you could see how somebody would eventually figure out how to make it automated, right? So if that's a problem, what's the laziest, easiest way to fix this problem? That's the 5, but if I did like that, or like that, or like that, it's like, is that a 1 or is it a 5? What can I do? How can I change my notation so that I don't have this problem and I can still be as lazy as possible? What would you do?
Finish the 1, like, yeah.
right? See, your mind is biased with what you know, right? Because you know what a 1 looks like, yeah? You're jumping too far ahead. Our brains, they always want to think that way, right? But we have to turn that inside out. It's amazing how much you have to learn and know to figure out how to unknow. Our filters that produce our reality, our false assumptions about what reality is, a lot of these false assumptions we never made, we inherited them. And it's really hard to strip them away to see what really is right before your eyes. It's really hard. Okay? And it's scary too. Your brain doesn't want to do that. You'll get evicted from the village and not survive. So there's built-in mechanisms to prevent you from becoming enlightened. Okay. Well, you could do that, but every time I do a 1, that's a lot of extra work because 1s happen a lot, right? And remember, we want to stay as lazy as we possibly can, yeah? So at that point in time, we probably wouldn't be like, I'm going to start writing every single one of my 1s like this with all this extra effort just to make sure my 1 and my 5 don't look the same, right? That would be too much work, wouldn't it? You could start doing it, but you'd be like within 2 or 3 minutes be like, this is way too much work. I can't do my 1s fast enough. What do you do if somebody doesn't understand what you just said?
Repeat it.
Right? That's the simplest solution. That's the simplest, fastest fix, isn't it? Diagonal. To make sure they know it's a diagonal, diagonal. Hence the Roman numeral 5. Now, anthropologists look at this and they say, well, they invented that because our hand looks like a 5. See my hand? Right? My hand, or I'll draw a picture. You see, this is the V, right? So because of that, I think they're wrong because they are doing what we just did, looking at things in hindsight, backwards in time. Sure, I look at my hand, I see a V, yeah? But that's not how things evolve. Time flows from past to future, right? So I think it was this other step of, I'm just going to say it twice. And yes, it happens to look like my hand is a V, right? Now, it is based on the hand because, remember, that came from the thumb folded over, right? And then replicating it just to say it's really a diagonal, it's not a 1. I think it's just coincidental that that we have a V in our hand. So I think right there is a unique discovery that all the scientists and historians are missing out on because of how they think. It's not what you think that makes you smart, it's how you think. When we start doing math problems, which we've already been doing this whole time, thinking mathematically, all right? Nobody cares about the answer or the question. Every example is just a playground, a cognitive playground, okay? So we are going to learn how to embrace these little tricks like multiplication to avoid repetitive addition. And then exponentiation, that's just repetitive multiplication, right? And that's all you need. Don't divide ever. You don't need it. Don't do anything else. That's all you need to be able to do with the math. Add, and add. That's it. There's nothing else. It is really simple. In this class, if it does not make sense to you at a 5-year-old level, you are doing it wrong. Okay? Math is hard because it's thinking. No matter who you are, there's this realm of stuff that you understand, and then there's this wall that's infinitely thick of the stuff that you don't understand, right? And when you think, you are walking right along that wall. Here's this cliff, right? Oh. And then, like, here's you. Hey. And you're like, I'm super comfortable with the green, lush world of stuff I understand, right? And then over here is like stuff I don't get, right? Whether you're Einstein or in pre-K, it's the same. There's what you get and there's what you don't get, right? And you just walk along that bluff. It's the same hard difficulty for every single person. It's the same for everyone. There's an infinite amount of math that I don't understand. And there's a little bit that I do. So it's not different. Like some people are gifted or what. Some people might know more math or might have learned more math more quickly, but they still have an infinite amount that they don't know. And so it's the same level of difficulty. And it's the same tricks of how to get those aha moments, how to sculpt your brain to get more and more neural networks present so that you can open up your reality and be more aware. Okay? The more you think, the more dense your neural network is, the more aware you become, and the more aware you become and the more you think, the more self-confident you are, because you're confident in your own ability to judge your own thoughts and judge your own judgment, and you don't need anybody else to confirm or affirm you as a being. That's what I want for you. Okay? No more being afraid of the dark. No more being afraid of what happens after life. All right? You can see past life and death if you open your mind up. It becomes trivial. And then you no longer have to resort to believing in things that are incredibly complicated stories. You can accept the simple, obvious facts right in front of your eyes that most people can't see. All right? So yeah, you're going to learn how to talk to people, but not directly because they can't understand the words that are coming out of your mouth. It's really an illusion that you say stuff, they understand what you said, and you communicated. People are animals wearing clothes. They are only perceiving your emotions, judging them in a knee-jerk, and then reacting to your emotions just like animals do. All the rest of that's just an illusion. It's not actually happening. There's very few people that are actually people. Remember, most people aren't the kind of people that invented or discovered electricity or cars or any of that stuff. They didn't discover anything. They were just handed all these comforts by a handful of people, and then they've used that technology and that power all day, every day, trying to avoid uncomfortable situations, and the result is they are destroying the planet as fast as they can so that they can avoid their own personal inconveniences only in that one moment. That's all they do. Okay? We don't want to be that way. It only takes a few of us not to be that way to change the tide, okay? I don't want my daughter to grow up to watch the sky catch on fire, so it's very important to me. Even though I was just an ignorant hillbilly, I am confident that I can actually change the world forever. Not by talking to people. If you want to change people, don't mess with them. Everything you are came from everywhere that you are not. People are like, where do you think you came from? Well, I didn't teleport here. Here's a math trick. If you can't answer that question, answer a simpler version. Well, I used to be this big, right? And now I'm bigger. So instead of saying where I came from, how about I just answer where this part of me came from? Well, that extra part of me came from, the food that I ate and the air that I breathed, right? That's where that part of me came from. Well, guess what? That's where the rest of me came from, too. It's that simple. People don't like answers like that, though. It's too simple. They want to come up with a complicated story. They're like, all the gods on the top of Mount Olympus and all this. I'm like, what? That's the most complicated thing. Y'all think math is hard? It's only because it's so incredibly easy. But the first thing you've been trained to do is assume that it's harder than something you can understand. And so instead of just using common sense and your basic reasoning brain, you don't do that. You just resort to it must be something incredibly complicated. And then that's why you can't learn math. That's why we make it that hard. Math is about simple ideas and a simple representation. All right, think about it. I like blue. I love the color blue. Check it out. I love It's a really simple idea, isn't it? Yeah? Look at the representation of that simple idea. There's 1, a space, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's a ton of symbols. Look at all those symbols. That's super freaking complicated. In here, we're going to talk about things like a point, a line. Super simple. Like if you're learning Spanish in a Spanish class, you don't talk about the technicalities of nuclear thermodynamics. No, you're like, I like plants. Right? So you can learn the language. It's the same thing in math. These are the simplest ideas that a human brain can think of. That's what we're talking about. And simple ideas should have simple representations. That's what math is. We used to not have math, but we still had to solve problems. We wrote the problems down with words in English. So now what we can do in math with just a few pen strokes used to be pages and pages and pages of writing stuff down, and it sucked. Think about if you had 5 cows and 7 cows in 2 separate fields, but you didn't have the words or concepts of 5 and 7. What you would have is 1, and plus just means and. So that one field as 5 cows, your brain would have to go, I have 1 and 1 and 1 and 1 and 1 cows. And here's the other field, 1 and 1 and 1 and 1 and 1 and 1 and 1 cows. So for us is simply 5 and 7. We call it 12. 5 and 7 is a great name for a quantity. Adding is simply renaming a quantity with a shorter name because we're lazy. But instead of calling it 5 and 7, I'm going to call it 12 because it's faster to say, right? Without the math, our brain has to take that simple idea, but call it 1 and 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 1, and you're already overloaded, right? Your brain's already overloaded with just 12 cows. Without math, you can't even think about 12 freaking cows, can you? That's the power of math. It's literally a superpower, and it's been refined for thousands of years, and we are just gift-wrapped, handing it to you, giving you literal superpower, making you a higher dimensional being than the people around you, and nobody sees it for what it is, or appreciates it or recognizes it. I'm hoping that you will. And regardless of whatever you've been taught in math classes before, that you will embrace it and utilize it and become far more of a human being than you ever thought you could be. You'll become more than you thought it was humanly possible really quick. Those are the tricks. So we have symbols. Y'all know these, right? What are these? We call them the number systems. They're made in India. We call them Arabic. But those are just shortcuts. Mathematics is tricks to avoid repetition, and it's also data compression. The goal is to free up the brain so that we can think about cooler stuff. So compressing data is one trick that does that. 1 and 1 and 1 and 1 and 1 and 1. That's takes time, and it takes energy for your brain to think that, right? We don't want to waste that time. We don't want to waste that energy to deal with 12, do we? That allows us to be more alive, because now we can take that time that we saved going 1 and 1 and 1 and 1 by saying 12 to think about cooler stuff, because we're alive. We get to do that, right? So this is just the newest version of that many, yeah? That's what it is. When you see that, that's what it means. It's an encoded quantity. So with math, there's only a handful of symbols. They made you memorize so much stuff. Don't memorize anything except the stuff that you absolutely have to, and the only thing you have to memorize are the symbols. When we step from this, an alien can figure out what that is, no matter how many fingers or if he had fingers or not. That notation is like natural, right? There's a stick for each of the quantities, right? Once we took the leap to that for 5, that's gone. An alien wouldn't know that that's 5 unless you told them, like, this is our version of 5, yeah? So there's a difference between those two types of notation, isn't there? Okay? So whatever it is, these symbols don't have to be these symbols. They will change and evolve along with us. Mathematics is the language that describes everything that we can possibly describe. Remember, the words are only for human stuff, right? So they need to evolve. The problems that we face in this world are going to change. And we need the language we use to describe them to evolve and change along with our needs. So what they're doing in math class is going to kill us all, because they think the symbols are the math. The symbols are not the math. Hopefully in 100 years, we won't use any of these symbols. We will have better ones. There's a lot of problems with our notation. And what y'all get hung up on isn't the math at all. It's sucky notation. And you can use your own notation. You can make up your own as long as you tell the reader what you actually mean, okay? So those are your symbols. Why do we have 10 of them? Because we have 10 fingers, as if the universe cares. Okay? Now when I do this, this is 1, 2. 1, 2. My daughter tells me it's 12. Why?
Because there's no space.
Because there's no space, right? What if I said, this is a number, I'll tell you how much it's worth later. And here's another number, I'll tell you how much it's worth later. What would that mean? We would call it A times B. Now, y'all have used this for multiplication. Don't ever do that. It's terrible. We are going to use X as a variable. And this is why most people fell out of math right away. Because for some stupid reason in math classes, they use this for multiplication. Don't do that. Don't do that. Because after 5th grade, nobody does that, ever. Okay? We would write a dot, right? Or you could put it in parentheses, yeah. Okay. Over here, it's implied you're multiplying these two quantities, whatever they are. You could do it either way, right? If you're in elementary school, you could put the cross there, okay? Because each of these symbols are known quantities, there is an operation present. It's called base 10. It's assumed we're working in base 10, another assumption. Again, you don't know what the symbols mean without context. The assumed context is base 10 number system. This is a shortcut for one, well, I'll abbreviate it more. This is really 10 plus 2. This is your ones place. This is your tens place. Remember that crap? There's a hidden plus sign, isn't there? This is why arithmetic is so freaking hard. There's hidden plus signs. Check it out. When I do 12 times 15, why is this hard? Because we're mixing operations. This is really 10 and 2. And 10 and 5. You are mixing addition and multiplication. There's two operations present. All right? Base 10 is a sucky way to represent numbers. The only reason we use it is ergonomics, because we grew up using fingers learning how to count. You use the fingers, I'm this many old, right? And then you ask your kid, like, what's 2 plus 3? Well, they go 1, 2 on one hand, they go 1, 2, 3 on the other hand, and they recount their fingers, right? It's so funny when I say, what's 5 plus 2? And they have to, they know there's 5 fingers on a hand. Instead of holding up their hand going 5, 6, 7, they have to go 1, 2, 3, 4, 5, 1, 2, and then they recount the 5 again. 1, 2, 3, 4, 5, 6, 7. And I'm like, oh, come on, you know what I mean? We still do that as adults without even realizing it, okay? So that's why arithmetic is hard. But again, that just means repetitive addition. That's what multiplication is. Now, let's figure out exactly what addition is before we move on, because that's our next symbol, right? We got 0 through 9 plus. We don't need the word plus, it just means and. If I do this, 2 and 3, this is what it used to be. 2 and 3. Look at how many symbols it took, how many pen strokes it took to write that simple idea down. That's a lot of pen strokes, isn't it? For such a trivial, simple idea. That sucks, doesn't it? But y'all are cool with English. I don't know how. It's the hardest thing in the world to learn. You can all read and write that crap. Every single rule doesn't make any sense at all. Sound it out. It never sounds out right. You know, you all learn that, but the simplest subject there is, math, you're like, that's hard. Why? Every single class in school, you could learn that all from watching documentaries on Netflix. Every one of them, except for math and like music and art. Those are the ones that require thinking, aren't they? The rest is just stuff to know, and guess what? Your phone knows everything and it's dead. Why waste your brain competing with dead objects? Don't do that. utilize the phone as a lobe of your brain. All matter is brain matter if you make it so. The calculator is now a portion of your physical brain. The computer is. AI, don't compete with it. Meld with it. Let it become you. And now you are more than human. That's what mathematicians do. That's what mathematics is. This is how we evolve. This is how we become more than what we were before. This is an abbreviation for this many. And. That just means and. 3 means this many. Yeah? So what are we doing when we say, oh, and there's another symbol, this guy, equals. That just means is. And as Bill Clinton once famously said in front of the whole world, it depends on what the definition of is. That's something really important to think about. You're going to see that we use this symbol a lot to mean lots of different things. And we just don't ever tell you. Y'all were taught math the worst way possible. Imagine if you're like in a language class like Spanish. My dad's a Spanish teacher, right? Where it was taught like this. If you hear these sounds, you make these sounds. And if you see these symbols written, then you write these symbols. And when you write an essay, if you don't write exactly the essay that I have written here, then it is wrong. And that's the whole class, every single lesson. That's how they taught you math. They taught you math with incomplete sentences too. There's other symbols that they never told you. There's ways to tie in these sentences to make paragraphs because the goal is to write coherent thoughts down, not just random buckshot symbols all over the paper where we box the final answer. Nobody cares. First, you have to be able to think mathematically. Just like you don't have to read and write English to be able to think, right? But if you want to put your thoughts down because you discovered something cool, like a new way to build a house, blah, 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 blah. Well, if you don't know how to write, it's really hard to share that idea, isn't it? Yeah? That's why you have to learn how to write, because you want to have ideas that are more complicated than ideas that only last 0.1 seconds. Yeah? So that's why you have to learn how to write mathematically. But it's really, really easy. There's only a handful of simple. We would say this, and that just means that's a shortcut for that, right? So what are we doing when we add?
Putting numbers together.
Right? This many is this many. We're not actually physically moving tally marks though, right?
Combining.
Not this day and age. Yeah. So hold up your hands, right? If you're like, if I have this many and I have this many, I have this many. No matter what you call it. If I have dos y tres,
Cinco.
yeah, tengo cinco, right? If I have 2 and I have 3, what are those? Those are just representations. Everything you write or the words that go through your head, those are not the ideas. Those are representations of the ideas. Does that make sense? This isn't math. The symbols are not math. They are representations of the math. Your entire reality isn't even real. Again, you don't see anything you think you saw, and most of what you think, your brain just assumed. Right? Quite literally, it just assumed based on past experience. What most people believed is real is simply a representation of reality, and they don't know the difference. They live in the flatlands. They're surface dwellers. They think the surface, this representation of reality, is the whole reality. They don't realize that that's just the skin of it. They're not aware of the rest at all. Okay, so 2 and 3, that's a great name for a quantity. This many, right? Dos y tres. That's a great name for the same quantity, right? Yeah? Or 2 and 3. That's a great name for a quantity, right? All these are names for an amount, yeah? This is a great name too. It happens to be shorter. When you say is, that is, What is adding? I never thought about it till recently. Adding, all you're doing is renaming the quantity. You're not actually doing anything. We didn't do anything at all. I just thought 2 and 3, that's a great name, but it sure is long. I'm going to come up with a shorter nickname called 5 because it's faster to say and faster to think, and I want to think fast because then I get extra time and energy to think about cooler stuff, right? That's where it begins. We're just being lazy, taking the name of a quantity and coming up with a shorter nickname for it. Now, dos y tres is Spanish, 2 and 3 is English, so that's not actually even math, is it? It's just language, right? Most math teachers don't know what math is at all. They think it's vocabulary and these symbols. These are just representations of it. They could change anytime we wanted to change them, which I hope they do because some of them suck, right? So I want you to think about as we go through the class, is this math or is this just English vocabulary relevant to the subject of math? Because if it's called perpendicular in English but something else in Spanish, knowing that word perpendicular and its definition, that's not math at all. That's just English vocabulary, isn't it? Yeah? They love to give you points and grade that kind of crap. As if, who cares? If you cross the border and it's called something else, that's not math. That's vocabulary. Got it? Okay. So now we know what plus is. Now if I have 2 plus 2 plus 2, and it goes on and on and on, that sucks. I don't like doing repetitive tasks. It takes too long. I want to think about cooler stuff, so we invented the concept of multiplying, right? So we did this, but that sucks because then when you get to algebra class, the students mistake multiplying with the x that we use for a variable, and it's a huge problem, right? I guest teach my pre-K, my daughter's pre-K class, and they would do this, right? And the students would go 3. They were doing freaking algebra in pre-K. And I told the teacher that. She's like, what? You're right. I was like, if you just didn't use the question mark and you used the letter X, they're doing algebra in pre-K. Wow. And I said, but then y'all screw it up because you dumbasses, as soon as you get from plussing to multiplying, you use this symbol for multiplying and you totally screw their brains up. Please just stop doing that. Just stop doing that. And everybody could be super geniuses and quantum physicists at the age of like 10 if they just stop doing that for starters, right? There's so many things they do wrong. So, back to multiplying anyways. So what I need to come up with notation, so we could do a dot. Let's do a dot. You could use the cross, but we're going to do a dot. We're going to use that, and all that means is that's a way of compressing data. Just like a photo file on your phone, you can compress it into JPEG or whatever. How does it do that? If there's any repetitive patterns, you can always compress the data. Anytime we have repetitive patterns, we compress the data. That's what math is, compressing the data. Now we can think about that same data faster with less energy and thus save time and energy to think about cooler stuff. This means this. You don't need an order of operations, mnemonic, PIMDOS crap that you memorize. No. Just decode it in the order that you invented it. So if you see this, 2 times 3 plus 4, remember, all we have to know is how to add, right? So it's all plus signs. So the first thing you'd have to do is turn that into this, because that's what that really means. Now you got it all pluses. So it's obvious that you have to do the multiplying before the addition because multiplying is repetitive addition. Does that make sense? Okay, cool. So we don't need PIMDOS. You don't need to memorize that at all. We just know what the symbols mean. Plus, times, and the number symbols. The parentheses screw people up. I just did this, right? Well, there's an obvious natural way to do that. Turn the 2, get rid of the times, turn it into pluses, right? But what if you didn't want the reader to read it that way? What if you didn't want them to do it that way and you wanted to do it the weird way? What if you wanted them to add this first and then multiply for some weird reason, right? That's not the way you would naturally do it, because again, you have to turn everything into plus signs. You would turn this into 3 2s. But what if you didn't want to do that? What if you were trying to write it the other way? You wanted to do 2 of 3 plus 4s, right? So if you have 2 3 plus 4s, here's a 3 plus 4 and a 3 plus 4. What if you wanted them to do it that way? Interpret it that way instead. There might be situations where you're like, I have 3 and 4. Oh, wait, here, I have another 3 and 4. How many 3 and 4s you got? Oh, I got 2 3 and 4s. Okay, let me write that down. Well, how do I write down 2 3 and 4s without it being 2 3s and 4? You see the ambiguity there? Hence, I'm going to put parentheses. That's the easiest, simplest way to now say I have 2 3s and 4s as opposed to 2 3s and a 4, because those are different things, aren't they? Yeah? Okay. That's where parentheses came from. Play with that idea. Come up with basic, simple 5-year-old situations where there's a difference between those, and play with them so that you can appreciate it, so that your brain can grow the physical neural network to be comfortable with that idea, that symbol. Because there's only 15 symbols in all of math. And if you know what they mean and can appreciate them because you played with them and discovered them, in your little world, in your mind, then you know all the math you didn't learn in 12 years. You can learn it in a few hours and comprehend it to depth that quick and that easy. Okay? So now you know parentheses. Now, they talk about the distributive property. Y'all might see this. You do the thing, right? Yeah? This is a 3 and a 4 and a 3 and a 4. We would write it like this. A 2 times a 3 and a 2 times a 4. They call it the distributive property. You take this number and you distribute it to all of those. And then they'll have you do things like memorize FOIL. If I have a number and a number times a number and a number, I'm going to make you memorize this so that you can do this algorithm and appear to have learned math, and I'll appear to have taught it, and all I did is handicap you, because you do the first, multiply those, the outer, multiply those, the inner, multiply those, and then the last, multiply those, and now I could do that, and I've got the answer. But as soon as I do something like this, now the mnemonic doesn't work, and you're screwed forever. And all it did was allow you to avoid understanding the distributive property. Check it out. 2 times 3 is, what is 3? 3 is really 1 and 1 and 1 and 1. This is just a fast way of writing that, yeah? If I want to double 3, I need to double each one. There's 3 ones, yeah? So I need to double the first one, and I need to double the second one, and I need to double the last one. You see that? When you break it down to the tally marks, which they just really screwed you by giving you these number symbols too soon. They should have made you deal with the tally marks longer so you could appreciate what they mean. 3 is 3. 3 ones. If I'm going to double 3, I need to double each of the ones that make up the 3, yeah? So I'm doubling 2 times each of the ones. 2 times each of the ones. You see it? To get comfortable with these basic ideas, play with the most trivial, simple examples to where it's blatantly obvious, right? There's no question at all. And then let it grow from there. So, yeah, play with stuff. If I have 3 and I have 4, you know that 3 is 1 and 1 and 1. You know 4 is 1 and 1 and 1 and 1. Distributive property. I would say, I could do it. 4 is 2 and 2, isn't it? Yeah? These are equal. So I can triple the first 2 and I could triple the second 2, yeah? Okay, cool. If I really exhaust myself and break it down to only ones, I'd be like, okay, I gotta do 1 and 1 and 1 times this one, and 1 and 1 and 1 times times the next one, right? And again. So I'd have to do it 1 and 1 and 1, and 1 and 1 and 1. Those are equal. 3 times 4. This is 3 times 1, and 3 times 1, and 3 times 1, and 3 times 1, right? 3 times 1, and 3 times 1, and 3 times 1, and 3 times 1. That's the same as 3 times 4. Here's the 4. 1, 2, 3, 4. I tripled each of the ones that make up the 4. See how many different ways there is to write this? It's a poem. It's art. Every single pen stroke on your piece of paper matters. The whole point of math is to condense simple representation of a simple idea. Every pen stroke matters. If you wrote a book, you wouldn't just write down a bunch of words and be like, done. You were publishing this, you would think about every single word, every single sentence, and in its arrangement, wouldn't you? Same thing with math. It's even more important because in math, it's more condensed. The fewest number of pen strokes. What do they mean when they say simplify? I never thought about it. I didn't even know what it meant until a few weeks ago. What the hell is simplify?
It's to get to like the simplest form.
Yeah, and there's some definition of that. I don't even know what most of them are because I'm a mathematician, not a math ed teacher, right? To me, it's always the simplest number, the fewest number of pen strokes to represent the quantity. That's the simplest for me, right? Really, it depends on what you're going to do with that number, yeah? For me as a mathematician, if I end up with this, whatever, a whole bunch of symbols, if all the symbols are Arabic symbols where they are representing known quantities, boom, I'm done. That's a known quantity, that's its name. The rest is calculator work. Calculators are dead, right? But in math class, they really like to make you do arithmetic. In fact, they never teach algebra at all in algebra class. They just have you, replace the letters with numbers, now do arithmetic. Calculators do that. They're dead. We invented them so we don't have to do that. So we're not going to do that. It sucks. Okay, so play with it. Don't simplify. If you're going to do math, don't simplify. Every time you simplify, you are hiding mathematical structure. Check it out. 2 plus 4 is 6. 2 times 3 is 6, right? If I'm just looking at 6, I just know what does that mean? It means this many. I don't know if that meant is it this or is it this? These are not the same thing, are they? This is not the same as that. They are not. Totally not. 2 plus 4, right? Here's 2, and here's 4. 2 times 3, that's 2 groups of 3. 2 piles of 3 is not the same thing as a pile of 2 and a pile of 4, is it? They're totally not the same thing. But when we put equals and we say this is that, what do we really mean by the definition of is? We need to understand this symbol, is. What do we mean by this is that? These are not the same thing. What is true, though? What is the one thing that's similar between this picture and this picture?
It's the same total.
Same total. So in math, in this context, when I say is or equals, what I mean is these 2 piles of symbols and pen strokes represent the same quantity, the same amount. That's what we mean by is. The definition of is, okay? So if I'm working with Arabic symbols 0 through 9 and pluses and multiplying, right? Whatever I have over here, if these are all known quantities, this is the name of a quantity. It's a great name. As a mathematician, that's the name. I'm done. That's the answer, right? Now my boss, who gets all the money from all the work that I do, he's not going to do any math at all because he doesn't know anything. He just has money, and money makes money, not people, right? All he wants to know is how many dollars he has, right? I will refer to quantities as fingers from here on out, right? Like, we know how many fingers that's worth, okay? Or the boss, he just wants to know how many dollars you made for him. That's it. That's why we simplify. It's for the rich guy at the end, right? Who doesn't want to do any math, right? If you're going to do the math, you want it like this because now you have the structure. I have 2 piles of 21, right? A pile of 2 and a pile of 21 here, right? You want to know that structure. That's what allows you to do the math. There's a bunch of different ways to solve a problem. You want to do it the fastest, shortest route. You have been trained to do it the longest way possible. Don't simplify. Every time you hide the structure, now you're taking the rules. The rules in English, the grammar, they tell you what you can do, what you can write, yeah? Not what you have to write. In math, the rules are what you can do, not what you have to do. But the way you've been taught is to simplify, which means you have to do what the symbols tell you to do. You are literally mindlessly being told what to do by symbols and pushing the pencil. It tells you what to do. You mindlessly push the pencil. You're just a pencil pusher. The symbols are doing all the thinking. That's not math at all. The computers could do that. Don't do that. Every time you take a 2 and a 3, don't turn it into 5. Leave it like this. Algebra is arithmetic, but done the laziest way possible. So pretend that at the end of class, you're going to be given a calculator to do all the math, okay? So just don't do any of the pluses or the timeses or the exponents. Just don't do them. Leave them there. And you're doing algebra. Because A and B are numbers. I'm not going to tell you how much they are worth yet. I will later. Y'all fixate on the A and the B, but you forget A and B is the name of a quantity, and it's a great name, and it's just as important as A or B. And until you know what A and B are, you can't rename that to a shorter name. 2 and 3 is a great name. Leave it like that. You don't have to turn it into 5 just because the teachers punished you if you didn't, right? It still takes me so much work not to do this. Check it out. 2 times 3 is 6. But I had this because I simplified. Get rid of all the pluses and the timeses, right? I'm doing what I'm told, doing what I'm told. And then I get this, and then the teacher's like, it's not simplified. What? Now I have to undo what I just did. I have to turn the 6 back into a 2 times a 3. Why? Because there's a hidden 1 in here. 2 over 2 times 3, yeah? Now here's the trick. When you put is, if these are known values and these are known values, what can you do? The only thing you can do, if I'm going to say this is that, the only difference, if I have a number and I know how many that is, I'm not going to tell you, but I know how many it is. The only thing we can do, our action button, our Nintendo button here, we have the plus sign and the plus, which is multiply, right? Those are our 2 buttons. So what can I do? I know those are equal because they're the same symbol, right? If all I know how to do is add or multiply, and that's all I can do, what can I add or multiply where these are going to say, where the is true? They represent the same quantity. Here's a number. It's equal to itself. But I want to do something, and the only thing I can do in math is either add or multiply. What can I add or multiply if this is going to represent the same quantity?
0.
Yeah, I can add 0 or multiply by 1. If I do anything else, these are not equal, are they? It's that simple. That's what I can do. That's all you can do. Otherwise, it's not equal. Those are the rules. That's what you can do. But guess what? 0 can look like anything you want, really. 2 minus 2, that's 0, isn't it? 1 could be 4 over 4. That's the number 1. There's an infinite number of ways to represent these quantities, but ultimately, those are the only 2 things you could do. How hard can that possibly be? 2 things you can do. And guess what? Repetitively multiplying is called exponents. And we do that a whole lot. So it has its own special notation. These are called functions. Adding is a function, multiplying is a function, exponents are a function. But we do them so often, each one has its own special notation. So if I do a little number up there up high, that's just quick way of writing 2 times 2 times 2, repetitive multiplying. That's it. Descartes, the guy who invented I think, therefore I am, and the Cartesian coordinate system, that was his notation. He popularized it. It was super popular, and that's what stuck. So we're stuck with it. It has problems. That's all that means. So the other thing I could do is raise it to the first power. Those are your 3 things. Nothing else. If you do anything else, this is not true. When you write your math on paper, this dude is the verb in the sentence. I see so many people writing crap down and there's no equals. If you don't put in equals, there's no verbs in your sentence. That means nothing is happening. You're just pointing and grunting. Do not point and grunt at me. When you write your thoughts on paper using these symbols, make sure they make sense to you. Every single pen stroke should be there for a purpose, and it should make sense. And then ask yourself, what I wrote down, can anybody else in this class understand exactly what I wrote down? That's the goal, to write your thoughts down on paper where anybody else can read it and understand it. And whenever you come to a final conclusion, the reader can be confident and convinced that your conclusion is true. Otherwise, who gives a crap? Here's the answer. I don't believe you. Right? You got to convince me. You're writing your ideas down. It starts with English. Math is condensed English. We're just compressing the data. All right? And there's a lot of problems with the notation. It sucks. Like if I do 2 cubed versus minus 2 cubed, most of y'all don't know, is this minus 2 times minus 2 times minus 2, oops, or is this a minus 2 times 2 times 2? Y'all don't know, do y'all? You don't, right? Unless you memorized it, in which case you might forget someday. Don't memorize anything, except for what these basic symbols represent. You will remember stuff for free because you will use it. You only remember stuff if you use it a whole lot, right? As soon as you stop using it, you forget. Don't memorize anything. That's a waste of your time and a waste of your gift of being alive. Memorize what the symbols that you have to memorize, and you'll use them enough, like 3, right? You remember that. You don't have to memorize it, right? You will recognize patterns because they will show up over and over, and they'll show up enough where you will just remember it, and you don't need to memorize anything at all, except for what equals means, the number symbols. There's only like 15 symbols you have to memorize, and you already know what they mean, yeah? Do not memorize anything else. Just follow the rules, play with it. So what I want y'all to do is anti-simplify. Start with your favorite number. This will be your daily exam. Y'all did the quiz? Everybody did the quiz today? Yeah, just tell me something about yourself in your own handwriting, not typing. Turn it to PDF and upload it to me, right? I want to make sure y'all all can do the tech stuff. So your daily exam, here we go. I should write this down, right? Your daily quiz, number 1. All right. C, announcement, right? Announcement, all right? And now the exam. I wish I could write faster, but writing is tedious. I wish they would like get rid of or upgrade writing. You know, when people like are deaf and they use sign language, they don't sign with their fingers, all the ofs and the these and the that's. They skip all that crap, right? People still know what you mean. Yeah. And you read with Braille. Have you seen Braille? It was invented by a 10-year-old kid. Yeah. Why don't we put all that together? When I read, why can't I be running my finger along the text to catch all the ofs and the these and the that's while my eyes get the other information? And can we throw some color into these symbols too? And then you get multiple sensory inputs going at the same time. You could read so much faster, it'd be so less boring. Reading's boring. Okay. Start with your favorite number. With your favorite number, okay? And then write a mathematically, right, grammatically correct statement and have fun. Here's an example. I like, I don't know, 17. No, you go with 12. This is really 10 and 2. And it sucks because base 10 sucks because the universe doesn't care how many fingers we have. But this is the language we use to describe everything in the universe, and the fact that we insist on this base 10 stuff because we have 10 fingers is what makes arithmetic so hard to do for us, right? A better way, the first thing you need to know about math, the first discovery is the fundamental, all right, this is the first thing you should have learned in pre-K, theorem of arithmetic. Okay? This is critical. I'm going to talk about constantly. Constant is the first thing they should have taught you. Instead of using addition and piles of 10, because, I mean, what is this? This is a pile of 10. This is a human's worth of fingers and 2 fingers, is what that means. All right? A human's worth of fingers and 2 more fingers. 12 is really a 2 and a 2 and a 3. 2 times 2 is 4 times 3 is 12. Yeah? 2 and 2 and 3 are prime. They are prime numbers. That means they are not divisible by any other numbers. You can't break them down. 12 isn't even a number. It's called a composite number. 12 is multiple numbers stuck together. Don't ever look at a 12 and see 12. I don't even have that many fingers. I hate 12. 2 is small. I'd rather have a bunch of tiny numbers. I can wrap my mind around 2 and 3, yeah? 12 is a lot. I don't like it. I'd rather deal with 2 2s and a 3. When I imagine 12, I see 2 2s and a 3 like Legos, color-coded, stuck together to make 12, okay? 12 is way too much to handle, but 2s and 3s are easy, yeah? Cool? So, play with this. Okay, well, I could rewrite this like what? Let's see. 2 is 1 and 1, right? Times 1 and 1, yeah? Times 1 and 1 and 1, yeah? That's about as much as I could break this thing apart, but there's an infinite number of ways to represent this quantity. This is called the simplified version, isn't it? I do not like it. If I'm going to do math, I like this as my final answer because I'm going to end up having to use that number to do something else because there's going to be more math to be done. If I'm going to have a quantity and I need to use it to do something, I want it to be represented in the most versatile way possible. And since I'm building a bridge and not a pile of human hands, this sucks. 12 sucks. I need it to be like this. That's the best way to represent the quantity if you're going to use it to do some more math. But if you're just handing the value to the rich guy who's like comparing the dollars you've made for him to his hands, then he's going to want it like that, okay? And keep going and have some fun. Remember, this is that, this is that, right? Now, I just represented these. I did a trick where I'm representing these values different ways, right? But I could also do this 12 times 1, yeah? And then I can do, well, what is 1? I could do 1 as a 4 minus 3, couldn't I? These are all equal. Now back here, This is where I stumbled across arithmetic after 20 some odd years of math. I did this. 2 times 3, I just reflexively turned it to 6 because I was told to do that without thinking. And for the 25,000th time I did that, and then I had to simplify the fraction, and this has a hidden 2 in it. I had to undo what I just did. I had to go back to this. I stopped and I was like, why do I keep doing extra work? Why do I keep doing this work and then having to undo it? Why do I keep compulsively simplifying just to have to unsimplify to then simplify? 2 over 2. 2 over 2 is the number 1. Now, I can multiply by 1 and not change the value. If I'm already multiplying by 1, I can choose not to. Canceling out is not an operation in algebra. Don't ever do that, okay? Why? Check it out. Y'all do this. Samesies. No. What you're doing is you are choosing not to multiply by the number 1 because not multiplying by 1 isn't going to change the value, right? So simplifying for y'all means do the operations, get rid of the plus signs, get rid of the multiplying, get rid of the exponents. You get rid of all of those, and then you have to seek out and find the hidden identities. 0 is the additive identity. It's in the language of addition, this is not a thing. You start off with 0. In the language of addition, 2 is really a shortcut for 0 plus 2. You started with 0 and then you added 2. The number 1 is your multiplicative identity. In the language of multiplication, it's really 1 times 2. But we should abbreviate that just as 2. Okay? You can see that because we don't just put over 2. You do 1/2, right? You put the 1 there. Yeah? Okay. We'll get to fractions here soon. Okay, so why do I say that? Because y'all do this kind of stuff. Check it out. 1 plus 2 over 2. You know that this is 3/2, right? Yeah? So why do you do this crap? Samesies. Now it's 1. You do that constantly. You don't do it when it's these symbols, but if I give you this, straight up, 9 out of 10 of y'all, you just do some weird nonsense. It doesn't make any sense. Why would you do that? A and B represent quantities. They are numbers of fingers. Okay? You cannot do that. Stop doing that. Check it out. When you do this, look, y'all think of the bar as divided by, right? I am taking 1. This is a shortcut for 1 is divided by 2 and 2 is divided by 2. If y'all have this, you're like common denominator, I can add the tops across. Y'all are so used to doing this, right? You get the common denominator and then you add the tops of that, so you memorize some crap like that, right? You've done that so many times you don't realize that you can go this way. The bar is below the 1 because I am dividing the 1 by 2. And the 2, so if you do this, you just canceled out this bar completely, and you are no longer dividing. There's a reason why it's below the 1. Yep.
I was told see the bars like upstairs and downstairs. What happens upstairs is upstairs, what happens downstairs is downstairs, and then you divide it at the very end. So it's like you don't cancel it.
That's one way to do it. That's super complicated. That reminds me of all the gods on top of Mount Olympus to explain why the wind blows, right? But it's a good place to start. So try to translate that analogy to something far more simple. All right? It's kind of deep because we didn't have numbers. Like, this was not a number for a long time. I mean, 3 wasn't a number for a long time. We finally got 3. Eventually, we got these negatives. But this was a ratio of a proportion. It was a ratio of 2 numbers, a whole number to a whole number. But 3/2 wasn't a number in and of itself for a long time. Okay? 9 out of 10 dentists say brush your teeth. Well, how many dentists is that? Well, 9 out of 10. Well, that's not a number, is it? 9 out of 10, is it? It depends on how many dentists there are total, yeah? That's why it's a ratio. When did it finally become a number in and of its own self? Well, how many dentists are there? Well, in math, if you don't know and you get to choose, you choose the simplest number there is, 1. And now it's a number in and of itself. Okay? Don't think of this as a division. If you never divide the 2 into the 3, then this is not a division symbol. Don't divide, ever. This is not 6 divided by 2. This is 6 times 1/2. That's what that is. Do not divide. Multiply by fractions. We had fractions for thousands of years. Quit turning crap into decimals. Quit it. Decimals are fractions. Did you know that? 0.678. What does that mean? Well, when you had quantities that were less than 1, but we needed to represent them, there was iterations and thousands of years before we finally stumbled across this thing, right? This is just a shortcut. Remember, that's the ones place. This is the tens place, right? This is the tenths, the hundreds. This is just a short way of writing 6 tenths and 7 100ths and 8 1,000ths. That's what that means. That's all the decimal is. It is fractions. You're using fractions. If you're going to use fractions, why have a whole bunch of them added up where the bottoms are only restricted to powers of 10, right? Why do that? If you have 5/7, that's the number. That's a number. That's its name. 5/7, 5 out of 7, 5/7. That's the name of the number. Do not turn it into some decimal, which is just another fraction where you're restricting yourself to powers of 10 for the bottoms of the fraction and adding them all together. That's so complicated. Okay? This is intuitive. 5 out of 7, like 5, and here's 7, okay. We used those for thousands of years before decimals were ever invented because they are so intuitive to us. But y'all have been so programmed to use this calculator, turn it into a decimal as if you're more comfortable with whatever decimal that is. Are you really? You any more comfortable? We only use base 10 because we have 10 fingers and it's ergonomic and it makes us comfortable. Well, guess what? In this day and age, we don't actually care if you are comfortable with this number. Are you any more comfortable with that number than you are with that number? You're not going to do anything with these numbers. The computers are. The computers don't have fingers. So why are we wasting all this time converting stuff to base 10 because we have 10 fingers? And we only do that because it's assumed that if we put it in piles of human fingers, that we will be more able to relate to that quantity. That's the only reason we do that. But we don't deal with the numbers anymore. We have computers to do that for us. So why are we still doing that? It's a waste of time and effort and energy. It serves no purpose. That is not math. That's not math at all. Right? Maybe it once was math, but here soon it won't be math anymore. We will not use base 10 numbers for any reason. A whole lot of stuff is not base 10. 60 seconds, 360 degrees in a circle. That's from the ancient Babylonians. It's base 60. And it still lingers because they were smarter than us. And that was, what, 6,000 years ago? Right? They're smart enough to realize that just because I have 10 fingers, most of the universe around us doesn't have fingers and it doesn't care. Maybe we shouldn't use 10 fingers to represent quantities of anything that doesn't have fingers. That's just stupid. We do math stupidly today. Hopefully y'all can change it. Okay. So y'all got some symbols. We need a break, right? Is your brain melting yet? Let's take a break, y'all. So y'all got the exam, right? I'll turn to this in PDF. Quit, leave me alone. You'll get this, because this is going to go on. What?
When was the exam gonna be?
Every day. I'm supposed to do all that boring stuff. The syllabus. Y'all know how to read, don't you? I'll go over the quick things. I don't like huge ass tests. It's not normal. When you wake up in the morning, you don't go, I'm going to solve 45 problems. No, you got 1, maybe 2 things you're going to deal with today, right? Okay. That's why I give you a test every day with 1 or 2 problems, the daily exam. It's not normal to come into class and have 30 problems that you're going to solve and all that. That doesn't make any sense, okay? And it gives you math anxiety, which isn't a thing. There's no biology anxiety, right? Math anxiety is a math ed way of relabeling PTSD, which is quite literally what it is. It's indistinguishable from shell shock. It's because they are killing you. They're doing it in public, and they do it to everyone, so nobody notices it. It's like if you, every day on Monday, you went to work and your boss just beat the crap out of you. If that was just normal, even though it's against the law, if that was just normal, people would accept it. Like, yeah, it's just beat the crap out of your employee Monday, you know? Everybody be cool with it. If you're all covered with pink polka dots in 20 years, nobody'd even notice anymore. It'd be normal. It sucks what's allowed to be normal. Just because it's average, y'all, does not make it normal. There's so much average people do that's just horrific. And nobody notices it because it's everywhere.
1:10 p.m.
Leave me alone. What is this? 8, 6. Dang it. All right. Maybe. Yeah, how do we compare things in math? A difference. The difference between this many and that many, right? You subtract. Don't subtract. We have negative numbers. Add a negative number. Don't ever subtract, right? But that's one way to compare. The other way to compare is the fractions, ratios, right? Those are the two ways. That's how you get what we call perspective. Without perspective, if it's the same for every single person, you can't see it. The things in our world that are always the same and never change is the first thing that you cannot perceive anymore. That's the first thing your brain filters out because it doesn't matter. It's not going to threaten your body and kill you. If it's always there and it never changes, that's the stuff that none of us can see anymore. That's your God, if you will. That's why we can't connect with him. We can't even be aware of him because it's everywhere and he's all the time, right? It's the first things we lose the ability to perceive because we don't need to perceive it to stay alive. It's only the things that are different from here to there. If it's different from here to there, we need to be aware of that difference, right? It's a great slogan. Need perspective? Make a difference. Most people don't do that. It's really hard to see through the realities. Like the things that are similar almost everywhere, it's like you have to pick at the paint to see what's really going on behind the scenes. Because just because it's the same, that doesn't mean it's not actually changing. It just changes just slow enough where you don't notice, like your friend's growing older, right? They're growing older right before your eyes, but you don't notice it, do you? But it's there. And it's kind of a good thing to be aware of, isn't it? That it's happening. There's so much around you that you are not aware of that you totally could be. An infinite amount of things happening all the time that are simple and basic and your brain could understand, but you don't even perceive it at all. Once you come out of this class, you will be aware of these things. You'll be like, oh, wow, there's so much that I didn't even know that was right before my eyes my entire life. There's things you know and other things you know. And you are going to make connections between these things that you always knew. And you'll be like, oh. And now you'll be able to understand those things you know and eventually appreciate them. Hopefully it won't blow your minds. Yeah, check out that. So you got the daily exam, daily quiz, one every day. The book. There's homework in the book. We'll do the homework in the book. You can start doing that. Look at the table of contents. I broke it. Table of contents, it'll tell you where the homework sections are. Start working the homework problems now, okay? You know how they tell you to read the book before you go to class to hear the lecture? Yeah? Because if you just hear this stuff for the first time, it's just a bunch of words going over your head, right? What they don't tell you is before you read the book, try to do the homework problems. Of course you can't because you don't know how to do them yet, right? But if you just read the book without doing that, then you're just reading a whole bunch of words that go over your head. Yeah? Try to do the homework. At least try to understand what the questions are asking you. Then when you read the book, it has meaning to you, and you relate that information to questions that you have in your mind, and then you actually get something out of that reading. right? Then go back and try to do the homework again, and then come to class for the lecture. That's the proper order of operations, okay? We want you to get the most out of your time and energy spent, not the least, which is how they've taught you to behave. It sucks. You know how you learn from mistakes, right? They always say that. You learn from mistakes. I give y'all homework and stuff, and so you do the homework and quizzes, and y'all generate all these mistakes, right? What do we do with them? We give them to the one person that doesn't need to see them, the teacher. And then we don't let y'all see any of the other mistakes. It's the dumbest thing you could ever do. If it was a corporation or a biological entity, it'd be dead or bankrupt immediately. Everything we do in this class is completely and utterly backwards, 100%, 180 degrees out of phase with what you would do if you were actually trying to learn math. Every single thing, every tiny little motion and action. It's amazing. I always knew math ed sucked until recently, and I realized, wow, this is like beyond torture. It's like, wow, they're literally sucking the life out of everyone in plain sight. Nobody notices. So we're going to stop that. All right. I'm running out of time. I'm tired. This is my only class I teach this summer, so you get all my passion. Man, when I have to do this 7 times in a day, it's so hard to do because my first class gets all my love and energy. And then after that, it's like, you mean you want me to do the exact same thing I just did? Like a Chuck E. Cheese animatron robot? I mean, you could have just recorded it and put it on YouTube. And I will not do what's already done on YouTube 10,000 times before, because it's just the math ed version over and over and over. Right? Y'all didn't pay all this money to see something you could already see on YouTube. Every textbook is a clone of every other textbook, right? For some reason, all the teachers teach exactly the same thing in exactly the same way, and they all think, I should make my own YouTube video. It's going to be just like all the other YouTube videos. There's no diversity at all whatsoever. I almost cured us of that globally 20 years ago. So of course, there's 2 versions of syllabus, which is maddening. Is it that one? I don't know, one of these. Just read up on it. It's so long. When I was a student, the syllabus was half a page. Homework, quizzes, but done. Now it's this legally binding contract stuff. So do the homework. You got to do the homework. You'll submit it to and read in the syllabus about how I want you to do that. Here's me and stuff. I don't have an office. You could talk to me before class, after class. Email me through Canvas. It'll go through my phone. Homework, do it in the book. Quizzes. Normally, at the beginning of class, we'll do a daily quiz. Y'all work together on it. Group work, right? And then I will work it. I want y'all to use the whiteboards. If we're going to stimulate your neural networks to maximize their growth and awareness in the time spent here, the reason why y'all invested money in cars and car insurance and bought gas and risked your lives to physically put yourself in physical presence with one another is to reap the benefit of that. And the benefit of that is that when you communicate and resonate, you have information flowing between each of your brains with all your multiple sensory inputs. So if y'all all drive here and then you don't speak to one another or ask me questions, that's just stupid. That's what most of my classes insist on doing. It's just like, get the hell away from me. I can't deal with a whole army of incompetent people that are like, I'm doing the most inefficient thing I can imagine possibly doing. This is how I do everything in my life. I don't want to be around those people. It sucks the life out of me. I will not waste my time with that. The best thing we could do is get rid of all these desks and chairs. You walk in, you get a marker and an eraser, and you work problems on the whiteboards. The teacher gets the only chair sits in the middle of the class. And like an orchestrator, a maestro, it's not about just maximizing the information flowing. Right now, it's all me to you, me to you, me to you, right? How much could that stimulate your brain and make it grow? Whenever y'all are at whiteboards, the output of your brain visually is projected, and then any other brain can visually see the output of your brain. And if everybody's doing that, there's now information flowing between everybody's brains, right? So it looks more like this. Instead of me to you, no, right? Instead of just that, you have you, right? What you're thinking could be seen by everyone, right? What you're thinking can be seen by everyone. What you're thinking could be, you see how it's like the information channels have opened up and it's like, mob, maximize bandwidth. But it's not just bandwidth, it has to be of the right nature. So just like the maestro, make sure that the musicians are playing the right sounds at the right time, right? That's what the teacher should be doing. This is how you maximize the stimulation of your neural network to make it grow the most, to make you more alive and more aware and more of you. That's what should be done. And it takes no computers or any of that crap. It's fun knowing how to engineer life. It's pretty easy. Just like a hacker can hack the internet and bring down the whole world from his mother's kitchen, you can hack humanity. Engineer the world around people. They won't even know you're doing anything. Engineer the world around us, and that is eventually what becomes the people in the future, because everything we are comes from everywhere we are not. So just like people hack the internet, you hack the world around us, and that is what sculpts the information flowing in and around us that eventually tickles the neural networks and makes the people become who they will become. So you can't convince an idiot of the obvious, but you can convince everybody in the entire world of anything you want by tinkering with the world around them. And they won't even know you're doing anything. Pretty cool, eh? So that's what my job is in this little room. Like harvesting gardens or something. If y'all have ideas, y'all share them with me, and I'm going to share them with the entire world. I'm going to try to teach every teacher how to actually teach math on this planet finally for the first time, because nobody's figured it out. This hillbilly that didn't know anything, below average person, just might be able to change the world for the better. Hopefully when my daughter grows up, she won't see the sky catch on fire. Hopefully we can divert that. We're going to save the world. Sounds ridiculous, right? It's actually pretty easy to do. If I laid down the list of tasks to do it, it would sound like the most boring 9-to-5 job you could imagine. Anytime you think of something that's impossible, that's impossible. You're lucky you even got around to making that assumption. Play the game of what if. Okay, well, what if it was? What would need to be for this thing I assumed is impossible? What would I need? What would need to be in place for it to actually happen? If you start playing that game, you're going to realize that a lot of things that everybody assumes is impossible is actually pretty simple and easy to achieve. A whole lot easier than things that we think are easy but are actually hard to do, you know? If not, you'll have fun. I mean, sometimes it is impossible, but you'll have fun playing that game. That's math. You'll be thinking mathematically. And from there, you'll have something cool to actually write down on paper, right? Why learn how to write math if you can't think mathematically? If you don't have cool thoughts to share, why learn how to write thoughts? Yeah? If you're just a mindless automaton, nobody wants to hear your thoughts. The other non-math people tell me, it's so important for your daughter to read. I'm like, it's important for her to think. I mean, what are you going to read? What happens if, there's nobody writing anything that's, valuable? Somebody has to be smart enough to write something down that's intelligent and unique and new for it to be worth reading. Somebody has to be that person. It's not just about following the leader. We need leaders. Apparently we need good ones, because right now our leaders are leading us right off the face of this planet into doomsday, okay? And any one of y'all can be the leader of the entire world, of all of humanity, forever and ever and ever. Any one of y'all. All you have to do is feel free to be. Have fun. This syllabus. Okay. I don't know, it's here. There'll be a final exam. I don't know what it'll be yet. The daily exam comes at the end of class. I'll give you a couple of problems, and you just get it turned in by midnight. You can work together if you want. I don't care. There's tutoring labs. You can work there. Use all the resources. All the things that they normally say is don't use because it's cheating. Use them, but not in the dumb way. Don't use the tools to avoid learning, because then you're just wasting time and energy putting on a charade. Use them to help you learn. If you're not using AI, you are wasting your life. Use AI for everything you possibly can, so you can be familiar with it, understand it, have a feel for how it's evolving, right? This is capitalism. If you're not using it, if you're not cheating, you're not trying, right?
You don't think AI is like ruining the world?
Not any more than the invention of writing. Aristotle thought writing was going to make everybody stupid because now you didn't have to memorize all that stuff. He thought that was really important for being intelligent, memorizing all the information that has to be passed on from generation to generation. Now you can just read it. You don't have to memorize it. Everybody's going to become an idiot. He was an idiot, all right? And a lot of things he said, people believed for thousands of years without even questioning it, no matter how obvious it was. Like women have a different number of teeth than men. Like nobody bothered to look for 2,000 years just because he said it. People are stupid. Don't be stupid, right? When I say stupid, I mean refusing to think. Feel free to think, question everything. Remember, everybody is wrong about almost everything almost all the time. There's so much room for improvement, okay? So AI is just a calculator. It's basically Google, but before the internet died. Like when I started college, there was no internet or cell phones or Google, of course. It took me a while once Google came out to realize I could ask questions about stuff that wasn't just classwork. It was like everybody was that way. It took a few months before we were like, oh, I could ask Google this. It's not restricted to just schoolwork questions, you know? The AI is the same way. Nowadays, you used to Google something and every single link that it gave you was made by somebody else and each result was unique and a different point of view. But that era is gone. It's died. The internet's dead. Now when you Google, basically during that era, whichever one got clicked on the most is what survived and everything else just faded away. So now the only thing you're going to get is what once upon a time got clicked on the most. You're going to get that copied and pasted over and over again. So it's just all the same shit over and over and over and over again with a whole bunch of commercials and crap. It's useless. So AI is basically just your new Google. It's a collection of all knowledge, and it's the fastest way to tap into what does Uncle Bob say, you know, about it, as if Uncle Bob was all the people in the world. And you can't accept that it's true. It might be that this is the best of what humanity guesses it could be for now. Treat it like that. It's just the fastest way to access that. If you want to know something, you just think about it, collect information about that question, analyze the information, right? So is it true or not? Nobody knows for sure. There's an infinite number of variables in reality. But are you confident that you collected as much data as you could concerning that question? Are you confident in your ability to analyze that data and look at it from as many different ways as possible? Do that, you come up with a conclusion, right? And then you go with that conclusion. I believe this is how it is. You might be wrong, and it never matters. Most people are wrong about almost everything, but there's no repercussions. You might be right. You'll never know the difference. But if you're wrong and it actually causes a problem for you, you'll become aware that you were wrong. In which case, next time you have a question and you're going to answer it, you're going to be more motivated to make sure you think about it longer. You're going to find more ways to collect data. You're going to find more ways to analyze that data so that whenever you come to your conclusion, you're going to be more confident that you are correct, right? That's where self-confidence comes from. And you don't need anybody else with a diploma or money to tell you anything. You don't need other people to know. That's what it means to know. And for you, as you get older and more wise, either you will develop more tools for collecting data, more and more data, and more tools for analyzing that data so that you can be more and more confident in your conclusions, or you don't do that. Like most people don't do that. Instead, they're like, I got to find the person who knows this. Well, that could be you. They live their entire life believing that the words that are popping into their head are thoughts. Those aren't thoughts. If you have an emotion and the reaction is words pop into your head to rationalize that emotion, those aren't thoughts. Those are emotions in the form of words. If you're just like, do I know this? Let me consult my database. That's not really thinking. That's just consulting your knowing database. And you are going to recognize that almost everybody around you, they literally do not think at all. And if you put them in a position where they have to think, even the tiniest little amount, they are going to freak out. They might attack you. It's really hard being a scientist in this world where your job is to have unique thoughts. With every single thought you have, you're creating something that never existed in the history of the universe, surrounded by people who don't, and they cannot value that. Check it out. The person who's doing the most important thing right now on the whole planet, when they're doing the most important thing that's ever been done, they're going to solve all the problems that are going to kill us all. This is what they look like. They look like they are doing absolutely nothing, right? Because they're thinking. That's the hardest part of any job. You think about it, and once you think about it all the way through and you finally know what to do, once you finally know what to do, then all you have to do is move your arms and legs to do it. That's it. That's the easiest part. The vast majority of humanity cannot even perceive or are aware of the hard part of anything. All they see is moving arms and legs, doing work. That's all they are aware of. It sucks being surrounded by the majority of society like that. And if you try to actually do anything to help anybody, they are going to punish you to death. Most of our best people are passive-aggressively persecuted to death, murdered in plain sight, right in front of everybody's eyes, and nobody even knows what's happening. So get ready for that if you actually become inspired. All right. Are we done yet? This is at 2:30. The class ends at 2:30. I don't know. There's so much here. Calculators are stupid. They only exist because the teachers are afraid you'll cheat if you use the calculator on your phone or your computer. So that's the only reason they sell calculators. That's the only reason they exist, is because of math ed and fears of cheating. Otherwise, nobody would ever make them or buy them. They're horrible little devices. Use your phone, the thing that you're going to have. You're not going to carry a calculator with you. And in math class, we never make numbers more than this many. You shouldn't need a calculator. Now, if it was engineering or physics where you actually measure stuff and it's some huge ass ugly number, you would use a calculator to do that, right? But in math class, we kind of stick with 1, 2, 3, 4. You don't need a calculator for that, do you? If you got 10 fingers, if you can count to this many, you don't need a calculator, okay? But what I do want you to do in this class is whenever you see this, it's a tiny number. That's just a placeholder. Pretend that that is this. Some big-ass number. Pretend it's a huge number. And then whatever process you did to solve the problem, if that same process wouldn't work, if this represented this many instead, then you're not doing math. You're doing it wrong. Okay? So pretend like this is a number that's so big, you would use a calculator to do it, because otherwise it would take the whole class period just to multiply these two numbers together. And we're not learning multiplying, are we? We're learning algebra, right? So pretend like it's a number that's so big to multiply it, even with a calculator, it would still take your whole class period to punch all the buttons and make sure you didn't make a mistake, right? Pretend that, because the example problems are playgrounds, and we want to play with the right part of it, right? Otherwise, you're just doing the charade part that we've been trained to do, and I'm going to do it repeatedly too, because it's so ingrained into me with all the years of math classes I took where I learned nothing at all. They may as well have made us memorize random sequences of zeros and ones. It's literally all we get out of it. So, what else do I need to tell y'all? Is that a good enough intro?
Do you have any like requirements or anything like to stay in your class? Because I know that's how I got dropped out from my last class. I had to do like.
Oh, I'm supposed to do attendance and all that? I used to have an attendance sheet. First day I would read off the names. After that, I'd make the students take turns calling attendance, because I thought it was important to learn how to pronounce people's names, because that's really hard to do. And no matter what you do in life, to be successful. It's about communicating with your tribe. And so it's like, you don't want to be anxious about like, oh, I read somebody's name, now I'm going to meet him, and be cool if like you had that skill. Like, I know how to pronounce that name. That's one less, source of anxiety you'll have in the future, right? And it also gets people to know one another. And so maybe we'll do that just for fun. You do learn more if you're here, period. That's why you're paying the big bucks, right? To have the privilege of coming here in person. We could do it via Zoom so that you could pretend to be Zooming and be playing Fortnite, it's up to you. Y'all are not going to use this math directly at all in your life, at all, are you? Any of y'all? How many of y'all have another math class after this? What do you have?
I don't know, but I know I have another one.
Right? The most important class of your entire degree plan. You just don't realize it because you don't see that. You apply it indirectly to every single thought you're ever going to have, but not directly to your job where you get the money, right? That's a shame. Hopefully I can help y'all with that. But this class, I don't want y'all to hate math more than you already do, or make it like make you feel even less confident about yourself like every other math class. I want to do the opposite of that, right? And some things in life are really important that you have to tend to, because life is hard for us not rich people, right? Sometimes that needs to be tended to more than this. I'm not about the algorithms. Every one of you is unique, and I want to be considerate of that uniqueness as much as I can. I hate grades. The more you try to assign a numerical value that judges how much your creative capacity for thought has grown, the less you're capable of actually achieving that goal in the classroom. All right? I want you to focus on the development of your mind, not the grade. Because the grade you could charade, and we could exhaust all of ourselves and get great grades, and I will look like the greatest teacher, and y'all will all look like the greatest students, and it will all be completely and utterly fake. And that's our entire education system to a T right now. And I don't want to do that. I want to do what I want to do, and I want to do it right, and I want to record it while they still let me teach, because they will eventually push me out. But I need enough evidence to support society, so when society goes, really, I'm not dumb, there's the math teachers that were just horrible, torturing us, let's do something about it. Hopefully society will stand up and make this change. And let mathematicians actually teach math again, instead of math ed people don't know what math is. A lot of them do, but not the majority. The majority control. And it's been, ever since math ed was invented, it's been gotten worse and worse and worse. I'll describe that in detail, why it is the way it is and how we can fix it, how we can be part of the solution. We don't need to tear down the education system. It just needs calibration. It's just a little tweak, a little tweak. It's like we invented the greatest nail gun, the most powerful nail gun in the history of humanity, and we're using it to nail all the wrong boards together. It's really easy not to do that. All right. Any other questions? So attendance, I guess I didn't answer that. I hope you will come. All right. You will get more out of this than any other experience you'll have in your entire life.
Do you do roll call or no?
What do y'all want to do? Y'all want to do attendance where we take turns reading the names so you all get good at reading names? That's mathematics itself right there. Y'all think math is like, well, there's one answer, it's right or wrong. No, that's not true at all. There's an infinite number of answers. They all represent the same quantity. Is it true or not? Well, it depends on the context of the situation, right? Check this out. What is that? What is that? Huh?
A coordinate?
Is it a coordinate where I go to the right 2 and I go up 3, boop, and I go 2, 3? Is that what it is? Or is it all the numbers between the number 2 and the number 3, but not including the number 2 and number 3? Is it an interval? same symbols, same picture, same pen strokes, two totally different objects. Depends on the context of the situation, doesn't it? All right? Check this out. And here you're going to learn this. What is it? Check it out. 2 cubed is 8. Well, that's just 2 cubed means this, right? Yeah? Oh, but wait, that's the same thing as 2 groups, okay, so let's see. 2 groups of 2, that's 2 groups of 2, right? 2 groups of 2, but we have 2 of those. 2 groups of 2 groups of 2. Okay, so there's 2 groups of 2, and here's 2 more groups of 2, right? That's 8 tally marks, right? So I just decoded it down to tally marks. 2 groups, there you go. 2, 2, great. I got 2 groups of 2. Okay, well I got 2 of those. 2 groups of 2, you see what I mean? That's what we mean by this. That's what that represents. 2 groups of 2 groups of 2. That's the same as 8. Okay, but we could also say this. 2 is the cube root of 8. Or why do we have this symbol? You don't need that symbol. The only reason that radical exists is because when printing press was invented, it was easy to typeset. You don't see that button on the keyboard though. Yet all the textbooks still use that stupid ass symbol. When most of y'all don't realize that what it really is 1/3 power as an exponent. And if you don't have it as 1/3, you can't do math with this stupid symbol. That's just a shorter way of writing to the 1/3 power. But guess what? You can type to the 1/3 power real quick and easy on the keyboard, can't you? But you cannot type the stupid radical symbol. But the reason the radical symbol was invented was because this is a lot faster to write than this. Because humanity does not understand what math is. We are going to make it a definition. There's no definition to math. I realized that the other day. That's why it sucks so bad. There's not an agreed upon definition. It's the study of numbers and shapes. That sounds like somebody whose job it was to write a dictionary came up with that. Definitely not a mathematician, right? The other definition is it's what mathematicians do. Those suck.